For this movie, we're going to run a test. This time, though, we're going to do it on a Superflow 110 bench, which has quite a few differences from the 600 style bench. And we're going to enter the data manually. We're going to type it in. So there's a couple of fairly big differences. And like before, I just want to tell you that this here is some pretty bad data I just simulated here on the bench. So if you see that flow curve, don't think that's real. It's not. And on the previous test, we did some port velocity maps too. But on this test, we're going to again click on Easy Start Wizard. Do I want to save my changes? No, because I've saved them already. And it says, do you want to run a similar test, just like the test that's on the main screen now? And I'm going to say no. It's going to be quite a bit different. Instead of a Superflow 600, we're going to do it on a 110 bench, and we've got no electronics. So then it disables these two specs. And you can see here the program senses that this is different than our master bench settings. And it says, are you sure you want to do this? And typically, you're not going to want to do this. You're going to want to always run a test on the bench you have, which is a Superflow 600 is what the program believes you have. That's because we told it those are the master bench specs in previous setups. But just to illustrate this, I'm going to say, yes, I want to do that. And it says the program will read the Superflow standard bench ranges as you run your test. What that means is you do not have to tell it on a 110 bench. It knows what the ranges are supposed to be. There's no factory calibration from Superflow. And obviously, because there's no data logger, there's no sensor calibrations either. So click on OK. What test pressure do you want to test at? Well, our 110 can't do 28 inches. That 28 is carried over from this test here. And we're going to do 18 rows of data. It's no big deal about leaving that. Bore adapter, let's say it's the same. Let's say that this is not the same. Their intake and exhaust adapters are those. Again, we're going to, CFM flow is going to be calculated from the data entries. The data entries are things like range and test pressure and stuff. Temperature, even though it says don't record temperature, because it's a 110 bench, the program knows that there will be a couple of temperature columns here, but we're not going to do barometer, humidity, swirl, anything like that. Pretty standard stuff. What do you want, lifts do you want to test that? And let's say this is what we want to do, except we don't want to go quite as high. Let's say we're going to go just a half an inch lift, and we're going to want to include a 0 point to check leakage. And do you want to record pitot tube velocities? We're going to say no. And let's say it's a 4-valve head. And let's say those are the valve sizes. And here, cylinder numbering. Here, we got 2 cylinders. Let's say it's a twin cylinder head. And we're going to start on cylinder number 1, but the step size is going to be 1. So we got cylinders 1 and 2 on this head. That's the cylinder numbering. Let's say that's the name of the test. And our folder name, let's say we put it in Jones again. And let's say that this stuff is, you can change this stuff, but let's say it just matches. And we're going to erase the comments. And when we finish, it's going to tell us our master flow bench specs have been updated and saved, because now you've told it, I'm going to run a test on a 110 bench. And the only way you can run a test on a 110 bench is you've got a 110 bench there that you're making measurements off of. Now here's something that's different for a 110. A 110 typically ships from Superflow with a little calibration orifice. And that calibration orifice is something that you periodically should check. You flow that orifice, you bolt it on where the head goes, and you see what it reads. Superflow, I think, says it's supposed to be 143.6 CFM or something. And depending on how close you read to 143.6, you may or may not need a correction factor. If you read low, let's say you read 140, you got to bump your numbers up some. If you read above 143.6, like 150, It's saying you're reading too high, and you're going to come up with a correction factor that's going to knock the numbers down some. So it's telling us that the test correction from wherever it's getting it, from the last time we were in a 110, which could be an example test that shipped with this program, is different than the correction that we have for this test on the main screen of 1. And the reason we got a correction of 1 is because that was a SuperFlow 600. It's just letting you know that that correction is going to be used with your 110. And here you can see we got the start of our test. It doesn't know what range we're going to run. That we have to figure out. But here's that test correction of 1.021. And let's say you wanted to do a test correction right now. What you would do is you could click on this, and a little screen would pop up. I guess I was wrong. It wasn't 143. It's 153. And you can say, how do you want to do it? You want to enter the test correction directly. Let's say you know that your bench is a 1.021 correction. Or you can calculate it here from CFM flow. And here is the standard flow that it's supposed to be. And let's say you go through your calculations and you come up with 150.5. It says, well, the test correction was 1.021 and now it should be 1.039. Okay, do you want to use that? And you click on yes, use that calculated value now. Now there's a number up here. This gets a little bit complicated. What is the measured flow without the test correction? What the program is assuming is when you measured 150.5, when you're supposed to get 153.2, that you were using this test correction right here, 1.021. And what it's saying down here is if you weren't using that correction, you would have actually measured 147.4. So it says if you went back and made your correction factor 1, you would be getting 147.4 for the number. So it's a little bit complicated that you have to understand that you measured this flow with a correction factor. And it's giving you this information here just as a reminder that that you may be double correcting. You got to be a little bit careful here. But let's assume that we did everything right. We measured this with our old 1.021 correction, and now we got a 1.039 correction. So let's say we're going to use that. Okay, it's going to say, do you want it also to be the current test correction for your flow bench? They say we're going to use it for the test, but do you want, again, sort of like the master bench specs? Do you want to be the master correction for your flow bench? We're going to say yes. So the next time you run a test on your 110, it's just going to assume that. So here's our test correction right here. So what we're going to do now is we're going to, let's say we set up the first condition, and because we're doing zero lift, we're going to do leakage. And let's say it's on range 1, the most sensitive range, and let's say we set 10 inches of water and we read 24% on our incline manometer, and the test temperature, because it's on the intake, the test temperature of the head, this is the one by the test piece, is 121. No, I'm sorry, it wouldn't be. It'd be room temperature. It'd be 79, let's say, room temperature. And the flow temperature would be warmer. It'd be 121, let's say. And it comes out with 2.4 CFM for a flow. That is the leakage flow. Because the valve is closed, but we're still getting a flow of 2.4 CFM. So you go in and type it up here. Oops. Okay, 2.4. And now you can see we got this at 0. Okay, now let's say we start opening the valve and start running tests. Okay, so let's say we're on range 2 now. And you can see a little diagram here of what range 2 looks like. And let's say we didn't get 10. Let's say we got 9.8. And it doesn't matter. The program will make the small correction to what it should have been at 10. Even though, so what you want to do is you want to measure the vertical manometer and tell us exactly what it is. And let's say at this one we got 45% flow, and again the intake was 79, and this time the outlet flow or the temperature up by the air orifice up at the top of your bench is, okay, we got 5.9 CFM. And this is what you would do. You could just type the numbers in. Let's say we're on range 3 right now. And we got, at this lift, let's say we got 10.1, trying to be real exact. And we got, again, 79. And here we got, again, 110. And you can see this is not making a lot of sense because it should be more of a straight line down here. But I'm just typing numbers in. I'm just pulling them out of the air. But let's say we wanted to go back, and the nice thing about doing this graph is, let's say you can go back and say, oh, that wasn't right. It's supposed to be range 3 there. And now this is looking more like a flow curve. Typically they bend this way. They don't bend like that. They most of the time bend more like that and bend over at the top. But let's say we wanted to go in and insert an extra data point. Let's say we wanted something at 25 thou of lift. What you do is go click over here on the 2. We want to insert a blank row, and there it is. So we can go in here and type, and let's say this time it is range 2, and you can see it gets highlighted there. And we set that up, and we get that. So this is how you would do it if you're doing data manually. And like I said, it's very handy to have this curve here because you can see it's telling us we're not doing a very good job. This is not what a typical flow curve would look like. This would be much more of a straight line. And just want to show you a couple things here. You click on Flow Bench, top of the main screen, and you can see here that when you say it's a standard 110 bench, most everything here is grayed out. The type of electronics is none, so there's nothing really much to enter. It's a very simple flow bench for the program to read. But you don't have to put in cal orifices and stuff, and because it's no data logger, there's no sensor calibrations. You click on Preferences. Preferences has got a lot of useful things in it. And for example, here, this main screen graph the flow coefficient. Flow coefficient is sort of a rating of the efficiency of the head, and it's really useful for flagging out problems. If your flow coefficient doesn't follow a fairly normal pattern, you know you got some problems in the data, and you can spot things right away and go back and correct for it. Another thing that we have here, where is it? There it is. The expected intake flow for test correction. This is that 153.2 that we use for figuring out the test correction. Maybe Superflow would have you an orifice that was maybe at 150.1 instead, some different number. This is where you can put that in for doing that. And you can see some people want a separate correction for the intake or the exhaust. So you could actually have two different corrections, flow the calibration plate in the other direction and have a different correction for the exhaust than the intake. So that's some things that preferences let you do when it comes to a 110 bench. So we're going to turn this on for graphing the flow coefficient. Click on OK, and now you can see this dotted line here, which is flow coefficient. In a good test, you're going to see this start at a fairly high value at low lift, drop down as you go up in lift, and once you get to 1/4 of the valve's diameter, it's going to start going up again. And it is a very handy thing to keep track of. And you can see in this one it's jumping up and down a lot more than it should. So it's kind of indicating that we got some funny looking numbers there. And you can tell also by looking at the flow curve, they look a little funny.